we're going from 0 to 12. So if we're going from 0 to 12 and we have 3 equal intervals, what are the x values that we're going to be sampling at? Those are the intervals, yeah. Correct? So if we're going to be using the right hand, we need to go from 4. What is it at 4? 10? Okay, let's use a different color here. Yep, let me get some axes here. So we have 4, 10 right there. And then what is it? 8 is a little bit higher. 12, and then 12 is back to 8. So then what are you going to draw? 3 what?
It should be lower. Lower than the 1 to 4 is 10.
Oh, thank you very much. Yes. Thank you. So it's at 8. So then what? We're going to draw 3 what right now? What shapes are we going to draw? Rectangles, right. So we're using the right-hand rule, so it's the height at each of these, like this. Is that correct? So this is going to be 4 times what? 10 right here. And this is 4 times 12. And this is 4 times what? 8. So we have 40 plus 48 plus 32. So what do we have? 1 what?
120.
We have 120. So that represents the overall area. So that's how much water. But what's it asking for? So what is it asking? Find the approximate average rate. So what are we dividing by? Do we divide by 12? And what do we end up with?
7.
Is that the answer? Is that, well, hey, remember, just because the methodology is easy does not mean it's an easy thing to do. You haven't done this in a long, long time. Is it A? You have the answer. I can flip back, but is the answer A? You see the Maserati driving around campus past few days? This like cobalt blue Maserati's been bouncing around East Hampton. I don't know. I just want the car. It's not what I focus on. I'm like, why? I'm like, there's my car right there. The blue is just amazing. I just want that color blue. Okay. The acceleration of a model car along an incline is given by a v at 0. What is v of t? So what are they asking you to do? How do you find the velocity? V of t is going to be equal to what? The integral of a of t? dt, right? Then we have an initial condition, right? So we'll have a plus c, and then we can solve for the use the initial condition to actually solve for the velocity. So what are we integrating here? We're finding the indefinite integral of t squared plus t over t squared plus 1. Y'all are the smart kids, so you can help me integrate that. How the heck do we integrate that? Come on. Well, it's kind of, but let's just take a look. Your big hint here are what the answer form are. There are lots of tangents here, right? There's also like multiple pieces. Any ideas? I have my idea. I don't know if it's the right idea.
First take out a t.
So when you say take out a t, what do you mean?
Well, you can like break up the
You could do this, right?
Yeah, but how does that help?
Again, math is not about doing the thing you know will work. It's about doing things until you find something that works. So yeah, we could do that. That is mathematically legal. What could we then do? Any ideas? So you might want to try some sort of use substitution, right? We don't have that many ways to integrate, right? There's not that many things we can cycle through, like by parts or by use substitution. I don't think this is by parts. Doesn't look like it. Maybe we could use substitution. The challenge, though, is what's the power of the numerator? 2. What's the power of the denominator? 2. They're the same power. We like it when they're 1 off, right? So it doesn't look like use substitution is going to work. There's another method that we can use to integrate things. We like to sometimes pull things apart. What's it called? Say it louder. Partial fraction decomposition. You know that really awesome thing that everybody outside this class has no idea what you're saying when you say it? So do you remember this? Side note, PFDs. We're looking for this. T over t plus 1 over t squared plus 1 is equal to, well, we'd have to try to we want to try to break it apart into 2 things, right?
Oh, a times.
Yeah, we can, but the problem, here's the challenge. What we factor the numerator. Usually when you're doing partial fraction decomposition, what do you want to do? You factor the denominator, right? Partial fraction decomposition, you have all the factors of the denominator, and then you break each denominator out separately, and then you do a system of simultaneous equations. In this case, t squared plus 1 is the sum of squares. We don't have a nice factor form for the sum of squares.
1 plus t squared is just like kind of like a tangent thing.
There's one other thing There's one other thing we might do. It's a trick that, so it doesn't look like PFDs will work.
So we maybe should just go back to the instrument.
So yeah, there's a bail. What's the, hold on, hold on. What's the bail here? The bail is we go back to the answers and do exactly what you just said, which is what? Just differentiate each one, right, and see which one works. Before we do that, I want to consider one more thing. Someone in my class last year, something I hadn't done before, we could take this and break, t squared plus t over t squared plus 1 is equal to t squared over t squared plus 1 plus t over t squared plus 1. It is, right? Right? So theoretically, if we could integrate them separately, I'm pretty sure we can integrate this one with u substitution, right? We let u is equal to 2t plus 1. I think it works pretty well. The question is, can we integrate this thing? I don't know. Before -1, yeah, I know what it looks like. I'm just trying to.
That's just how I think about it.
It's a sideways parabola. That's fine. That's right. Okay, when x is 0, what can y be? Plus or minus 1. So yes, this is a sideways what? Nice. And it says, is bounded by that and the y-axis. So what are we looking at for a region here? We're looking at, it's a parabolic triangle-ish, whatever. Not a technical term, but we'll use it. What is the volume generated when r is rotated around the y-axis? That's pretty cool. So at least it's rotating around the y-axis. At least we don't have to take any repetition into account where it's rotating on itself. So what is this sucker doing? It's rotating like this, right? How many of you did you draw one of the washers? Or sorry, one of the discs? Anybody draw one of the discs? Yeah, you have little discs, right? You have little discs. Oh, I'll use a different color. What do we have here? So there are our discs. Are we going to be integrating with respect to x or y?
With respect to x. No,
How do you figure it out when I draw the washers? It's whatever the little itty bit part is, right? Is that a piece of the y-axis or part of the x-axis? It's part of the y-axis. So we're integrating with respect to y. What's our lower bound of integration?
-1.
We could go from -1 to 1, or we could do 2 times 0 to 1. Pick the positive when you can. That's what I'll do. What's the volume of a disk? Pi r squared h, and in this case dy, right? Are you with me so far? So what do we have here? I'm going to just go from 0 to 1, and we have pi r squared, and we have dy. Now what's the last thing we have to do before we can integrate? Yeah, we have to figure out what r equals. And do we want r to be in terms of x, or do we want r to be in terms of y? Yeah. We know that that distance right there is x is equal to what? Oh, is it already nicely written in terms of y for us? Is that what, I think that's what the equation is, right? Yeah. X is y squared minus 1. We want this distance from here to here, and we want it in terms of y. Do we already have it in terms of y? Yeah. So r, in this case, is equal to y squared minus 1. So what are we integrating? 2 pi 0 to 1 of what? Y squared minus 1 squared dy. I'm not going to do that out. You can do it yourself. What's the best method for integrating that? What should you do first? Expand it. Yeah, just expand it. Like there's, remember, just because you want to find some like clever way to do it doesn't just take 10 seconds, clean it up, and then integrate. Is that one good? Draw pictures when you can. For me, it all comes down to like, where's that skinny little slice coming from? Where's that skinny little slice coming from? Finally, the something something of the something. And those were very, very specifically chosen blanks. What is that?
As h approaches.
No, don't read me the story. It's like telling me like, who wrote this story? And you're like, to be or not to be. No, who wrote it? Like, what is this? This represents something. What does it represent? This is the limit. Definition of derivative of a specific function. Take a guess what the function is. Sine inverse. Right. That's the limit definition of sine inverse at a specific value. At what? At 1, exactly. Look, as h goes as h goes to 0, right? What's going on here? What's going on? H is getting really, really small, right? So this is, so what is sine inverse of 1, everybody? Pi over 2. So this is, if you write this out, they simplified it a little bit, so you have to remember what it is. It's the limit as h goes to 0 of sine inverse of 1 plus h minus sine inverse of 1 all over h. That's too blindingly obvious theoretically, right? So they did, what is sine inverse of 1? Pi over 2. So what are they asking you for? They're asking you for what is the derivative of sine inverse of x at 1. So the question is, first of all, what is this? What's the derivative of sine inverse? What is it? 1 over what?
1 square root of x squared minus 1.
Is that it? Do we agree with that? Yeah? Okay, so then what is it asking you for? It's at what point? At 1. When you plug in 1, what do you get?
Undefined.
I think it's E? Yeah, it is E. The AP test is probably the most specifically designed test you will ever take because they will test these questions to high heaven. They'll give this question to 1,000 kids without giving them an answer. They'll look at the most common 5 answers and give those as the potential answers. Yeah, they're very specifically looking to give you answers that look tantalizingly close to what you want them to be. You guys, when you see slope fields, you should feel what?
Good.
You should feel really happy. Because if you get a slope field free response question on the PC calculus exam, that's when you like get up and start dancing until they yell at you to sit down. Actually, really don't stand up. They might actually kick you out. But the point is, these there's so few directions you could go with these. There's so few directions. So when you're trying to figure out which differential matches this, what's a really great way to do it?
Plug in numbers.
Just plug in points. So for example, whenever y is 0, it looks like, what is it? Is it undefined? Or I can't tell when I'm looking at this. It doesn't look like there's anything there, right?
They're dots.
They're dots? Oh, so what does that mean? Undefined. So you have to figure out for which one are they undefined? A, B, and no, just what? Just A and B, right? Because it's 2x, and x minus y. Like x minus y is not always undefined, not always 0 when y is 0, right? If x was anything else, so we've already narrowed it down to A and B. We've already gotten down to 2. At this point, you definitely guess, even if you knew nothing else. Absolutely. So then, how do you tell the difference between these two?
X is 0.
Ah, when x is 0, what does it look like? It's always what? It's always negative. Let's see here. Did we do something wrong here? Let's find out.
No.
Find k so the relative minimum of f of x occurs at x equals 1. So what has to happen? What's one of the things that has to happen for a relative minimum to exist at a point? Derivative has to be what?
0.
So we know that f prime at 1 must be what? 0. So what is f prime of x going to be equal to on this one? 3x squared. Yep. 1 over k plus what? X. So we know when 1 is plugged in, what do you get out? 0. So 0 is equal to 3 minus what? 1 over k plus x, right?
Oh, so you.
Oh, k plus 1. Sorry. Excuse me. You're absolutely right. K plus 1. So we have 1 over k plus 1 is equal to 3. So 1 is equal to 3k plus. So negative 2 is equal to 3k. So k is equal to negative what?
2.
Negative 2 over 3? I think we're done then? Was that too easy? I think we're okay. Right? We're done. There's nothing else to do on that one. Good.
Will they trick